Okay, continuing on, this is section 2.2, video 2. So what I want to do is take this equation and I want to write it in the standard form for a circle so that I can figure out the center and the radius. So again, as many times as I can, I'm going to try to memorize this formula: x minus h squared plus y minus k squared equals r squared. So what I have to do is something called completing the square. We've done that before, but I've got to do it with two variables. So what I'm going to do, I'm just going to write x squared minus 6x. Those are my x terms. Okay, I'm just going to leave some space there. And then plus, and I've got y squared plus 10y. I'm going to leave, let me back up, leave a little bit of space there. And I've got plus 25 equals 0. So first thing I'm going to do, I'm going to move this 25 to the other side. So I've got x squared minus 6x plus y squared plus 10y equal negative 25. Now what I want to do, I need this x minus h to be something x minus h squared. So basically I need to make this a perfect square. The way we make this a perfect square is I take 1/2 of the number you see here, that's 6x. So 1/2 of 6, that's 3. So I'm going to add 3 squared. Okay. And then if you look at this number 10, what is 1/2 of 10? That's 5. So I'm going to add 5 squared. So if you look at the way I've changed this equation, so I've added this and this, okay? So if I add that to the left side of the equation, I must also add that to the right side. So I've got to add 3 squared and 5 squared to the right side of the equation, okay? The reason we did this is because now this factors. So if you just remember, this is what, x squared minus 6x plus 9. That means if I can find two numbers that multiply to 9 and add to negative 6, that's x minus 3 times x minus 3. Because minus 3 times minus 3 is 9, minus 3 plus minus 3 is minus 6. So this just becomes x, whatever that sign is, minus whatever that number is. That's x minus 3 squared. Okay, that's part of the center of the circle. And then over here, I'm going to have y plus 5 squared. So you take that sign and you take this number, y plus 5 squared, equals, and then what is negative 25 plus 9 plus 25? That's not a 29, that's a 25. You add those numbers up and you get 9. Okay, so if you look at it, now I have the equation of a circle. Okay, since this is a positive number, that tells me my radius is 3. So this circle has a center of 3, negative 5, and it has a radius of 3. Okay, so again, it was completing the square that was the key for us in order to get this in the equation of the center radius form of a circle. So that was all of us working that, and there we go. Now let's look at another example of this. So now I've got another equation. I want to put it in center radius form to see if it is a circle and figure out its center and radius. So in this one, I've got 2x squared plus 2y squared minus 6x plus 10y equals 1. Okay. Now to do this completing the square, instead of a 2x squared, I really need that to be an x squared. So I'm going to divide everything by 2. So if I do that on both sides of the equation, I get x squared plus y squared minus 3x plus 5y equal 1/2. Let's gather the x's and the y's. So x squared minus 3x and then plus y squared plus 5y equal 1/2. So what I need to do is to complete the square, I'm going to add what's half of 3? That's 3/2 squared. So I had half of that number squared. Over here, what's half of 5? That's 5/2 squared. And then I need to add that to the right as well. So I'm adding 3/2 squared and 5/2 squared. So what this becomes, by taking half of that number and squaring it, I've made this a perfect square. So this is x minus 3/2, all of that squared, and then plus y, get the plus sign there, and then this 5/2. And then I just need to figure out what is 1/2 plus 3/2 squared plus 5/2 squared. That is 1/2 plus, when you square 3/2, you get 9/4. When you square 5/2, you get 25/4. So this is, I'm going to rewrite 1/2 as 2/4. So plus 9/4 plus 25/4. And that all adds to be 36/4, which is 9. So this is my equation. So this is a circle that has a center of 3/2, -5/2, and it has a radius of 3. Okay. So completing the square is a real key skill and manipulating these equations so that you can get the center and the radius of the circle. So that was the one that we just did. Let's take a look at this next one. We're going to work on this equation right here. So again, it's x squared plus 10x, and then I'm going to add something to complete the square. So y squared minus 4y, and I'm going to move that 33 to the other side of the equation. So -33. So half of 10, that's 5. So I'm going to add 5 squared. Half of 4 is 2, so I'm going to add 2 squared. So that means I have to add 5 squared and 2 squared on this side of the equation as well. So on the left, I get x plus 5 squared plus y minus 2 squared. And on the right, I get -33 plus 25 plus 4. And so that is what? So that's 29, that's -4. Okay. So in this case, when I look at this, I'm tempted to say the center is -5, 2, but the radius is not the square root of -4. The radius has to be a positive number. So this is not a circle. So this is not a circle. Because if I put it in the center radius form of a circle, I need a positive number to the right of that equal sign. I can't have a radius of a negative number. So there is no circle that meets that equation. Let's take a look at an example to end this section up of an application. So they say you've got receiving stations A, B, and C are located on a coordinate plane at the points 1, 4, -3, -1, and 5, 2. Let the distance from an earthquake epicenter to these stations be 2, 5, and 4. Where on the coordinate plane is the epicenter located? So if you think about it, I've got, epicenter, I've got something that's going to be the center. So these are going to be the centers, 1, 4, -3, 1, and 5, 2. These are the center of circles that are measuring the earthquake vibrations. So I want to look and see where these circles intersect and determine what that point is. So let's graph these first, and I will try to do this accurately on my inaccurate graph. 1, 4, 1, 1, 2, 3, 4. So 1, 4 is right here. And I know that that circle has a radius of 2. So at a radius of 2, so right here and right here, somewhere out here. So I've got some circle that does something like this, okay? I've got another circle centered at -3, -1. So 1, 2, 3. So -3, -1, centered right here with a radius of 5. So that radius, I look at that circle, 1, 2, 3, 4, 5. So right here, 1, 2, 3, 4, 5, something like this. And 1, 2, 3, 4, 5. This 1, 2, 3, 4, 5, something like this. So I've got a circle that's doing something like this. Okay. So this is circle A, that's B. Circle C is centered at 5, 2. So let's go find 5, 2, 1, 2, 3, 4, 5, somewhere out here. It has a radius of 4 units, 1, 2, 3, 4. So somewhere right here, 1, 2, 3, 4 here, 1, 2, 3, 4 here. So you see the circle doing something like this, somewhere up here. Okay, so this would have been better on a piece of graph paper. It looks like there's a point here, okay? 1, 2 looks like about where those circles are all coming together. So what I want to do is just to figure out, okay, if it looks like those are coming together at 1, 2, let's just check and see if that's the center of this earthquake. That would have to lie on all 3 circles, okay? So let's write the equations of each circle. So equation A, I've got a circle that's centered at 1, 4. So that's x minus 1 squared plus y minus 4 squared equal. It has a radius of 2. Okay, so let's just check. So what I would do is check for the point 1, 2. Okay, if I do that, then I get 1 minus 1 squared plus 2 minus 4 squared equal 4. And this becomes 4 equal 4. That's a true statement. Okay, let's check B. Okay, the equation of circle B is going to be x plus 3 squared plus y plus 1 squared. That circle is centered at -3, -1, and it has a radius of 5. So that's 25. So let's check the same thing. Let's check the point 1, 2. So if I plug that in, I get 1 plus 3 squared plus 1 plus 2 squared equal 25. So that gives me 16 plus 9 is 25. So 25 equal 25. Okay. And then the last thing is to check for the circle C. So C, that circle is x minus 5 plus y minus 2 equals 16.